Hello, and welcome to Chapter 9 Homework. Doing 10 questions over estimating and confident intervals. Yeah, I know. Doing lots and lots of fun stuff. So, starting off with question 1, we have a sample of 245 observations is selected from a normal population with a population standard deviation of 28. The sample mean is 17. Okay? Determine the standard error of the mean. Alright, so this formula is, of course, going to take the standard deviation divided by the square root of our observations. So let's get our calculator out. Here's our calculator. So 28 divided by 245 square root gives us about 15 point. Oh, did I actually answer that? There we go. I didn't press enter. So it is 1.789. Again, we need to round to the nearest one. So again, always hit check my work. So we take the population standard deviation and again divide it by the square root of our observations. Alright. Now, determine the 95% confidence interval of the population mean. Okay. So, we do know that the 95 percentile is 1.96. Let's go ahead and check out our z-tables. Let's go find our z-tables. So in our book, right here, z. All right. So remember, with 95, we have to divide by 2. Again, in order to find your z-value, you have to take whatever confidence interval you got, divide by 2, which is 0.95. That should be better. So 0.475, and then we would have to find it. So, and there it is. So that is 1.96. Okay, even though it says up here, it's good to do in case you got like 99 or other z values. So with that, we have to create our margin of error. All of a sudden, I'm blinking. I'm sorry about this, guys. So we're going to go ahead and all right. So we're just going to pop up the formulas, show you the formulas again. So this is the formula that we're dealing with the confidential interval. For some reason, my brain was just not working correctly. It happens. So we're going to take the z value that we know, 1.96, and multiply it by our answer up here, standard error of the mean. So, calculation, 1.96 times 1.789 will give us 3.50644. Again, we're going to keep it rounded, so let's see, it says round 3 decimal places, so we're going to keep 3.506. Then we're going to add it to our sample mean, which is 17. So this would be my high, 20.506. Now we're going to find out the low, which is now taking 17 minus 3.506. So 13.494. There we go. Check. And we are complete. We're good to go. Okay? Again, it's just really knowing the formula. So when it looks for margin of error, it's just looking for the sigma divided by the square root of our observations. And then we have to figure out the z-value based on the confidence level, which again, you have to divide by 2, find the decimal in the z table, and then from there, multiply it by the 2. Okay, probably going to have it a couple more times throughout this chapter. Next, question 2. The U.S. dairy industry wants to estimate the mean yearly milk consumption. A sample of 14 people reveals that the mean yearly consumption to be 60 gallons with a standard deviation of 20 gallons. Assume the population distribution is normal. We're going to use the T distribution table. They actually give us a link to it, which is awesome. So, since we're using T, we already know that this is going to be unknown. Okay? B, what is the best estimate of this value? Estimate of population mean. Okay? So for us, this is really just calculating the T value. So, remember to calculate T value, we have to go look at our T chart. Go ahead and just click the link. Whoa, this is a unique one. So this is your link right here. We're going to go ahead, and I like to use the one that's in the book. So we're going to go back to the book one. So right here, under T distribution, we're going to look at 95. We'll put this in blue. And then we need to find our sample, 14. Remember, for T value, since it's a sample, we minus 1. So it's going to be 13. So 95, 13, that is the third column, is going to be 2.160. Okay. 2.160. Check. Might went a little bit too, oh, yeah. I'm thinking this one. I went a little bit too far. So, our best population mean, I don't know why I was doing T value. I was moving ahead. That happens. So, estimated population mean is your sample mean. Basically, this one right here. Okay? Oh, I can't believe I did that. You can tell. It's like April fooled myself on this one. You can tell the date, but that was funny. Okay, so we have figured out the T value already. It is 2.160. Okay, check. Both answers are correct. Oh, I can't believe I did that to myself. So what is the margin of error? Okay, margin of error is going to take the t, and then it's going to take our standard deviation, and then divide by our square root of our sample size. So, calculator, I'm going to take, first I'm going to do the standard deviation, divide by our square root of our sample size, and then multiply it by that 2.160, which was our t-value. Answer being about 11.4546, because again, 3 decimal places. Okay, notice that I'm always constantly check my work since they are step by step. Okay, so now it's time to develop the 95% confidence interval. So we're going to take our 60 and basically add and subtract this number right here. So calculate 60 minus 11.546. We come out to 48,454. And then 60 plus 11.546, 71.546. Again, check. And then it's going to ask you the question, is it reasonable that the population mean could be 52 gallons? Okay. I think y'all can figure that one out. Because again, that's multiple choice, and I'm not going to do multiple choice answers. But I do want you to understand if it is or not. Okay? So, make sure when you answer that, why is it like that? Alright. Still can't believe I did that to myself. Oh. Alright. Netflix is considered a new romantic comedy series. Before making a final decision, the producers design an experiment to estimate the proportion of viewers who would watch the series. A random sample of 560 viewers was selected and asked to watch the first 2 episodes. After viewing the episodes, 350 viewers indicated that they would watch the new series. Okay. Estimate the value of the population proportion of the people who would watch the new series. Alright, so for this population proportion, this one's a really more simple one because we're just finding the proportion of the ones that will watch. So we take the 350 that said that they will and divide by the total. So it's 0.625. Okay. Proportion's a little bit easier. Now it's developed the 99% confidence interval. Alright. So we need to go ahead and see how to. So let's go look up our PowerPoint, making sure, because we're dealing with proportions, and I want to make sure I don't give y'all something. So we got proportion plus or minus z with those items. So, and we're at 0.99. Okay, so I can show you how to get to 0.99 confidence level. Okay, so back to our charts. Ooh. Okay, so we're going to be looking up the 99% wanting z value. So calculator, 0.99 divided by 2. We're going to look for 0.495. Almost there. So we're close right about here. 2.57. Yeah, about 2.57. According to ours. So our Z value is 2.57. Okay. So let's go ahead and bring back up our formula so we can see how that goes. So there it is. We'll zoom in so you can see it. Alright, so there's our formula right there. So really the best thing is to go ahead and do the first part before multiplying by the Z value. So 0.625, clear, 0.625 multiply by 1 minus 0.625 divide by n, which our sample size is 560. Okay. Then we get to find the square root of it. So square root they go a little too far. Alright, square root of that. No. Calculator wants to have fun. So we're going to go ahead and put it on parentheses and see if we can square root it all. No, I don't think that will work. Okay. Equal. Then square root that. There we go. And then finally multiply it by our 2.57, which comes out to 0.0525. Okay. So again, we're going to go about 3 decimal places. So since that is, we're going to go 0.053. 0.053 plus 0.625, and hopefully all of our rounding did not mess things up. So 0.625 minus 0.053 . 0.625 minus 0.053, 0.572. Okay. Let's see if our rounding did not mess things up. Nope. Okay. Close enough. Alright, so they will have some rounding issues. So, just be very cautious. If you are doing the calculations correctly on this one, please let me know, and we'll see if we can fix it. See how far you're off. Alright, question 4. A population standard deviation is 13. We want to estimate the population mean with a margin of error of 3 with a 99% level of confidence. Alright. So, with this one, we're going to take the formula. Now we already know that this is 2.57. So you take your confidence level, the z value of that, multiply by the standard deviation, divide by the margin of error, 3, and then we're going to square it. So it looks like we're at 124.02, and since it's a sample required, again, remember, we have to round up. This is going to be 123. Oh, not 123. I rounded the wrong way. 125. Sorry. I don't know. I am not doing so well. All right, check. And there we go. So this one, if you want to look at your PowerPoint, it is this formula right here. That's the formula we just did. So z value times our standard deviation divided by our margin of error squared. Okay, question 5. That was really less complicated. All right. So suppose the U.S. president wants to estimate the proportion of the population that supports his current policy towards revisions in the healthcare system. This sounds very familiar. The president wants a margin of error of 0.03. Assume a 90% level of confidence. Ooh, 90%. President political advisors found a similar survey from 2 years ago that's reported that 65. This sounds very, very familiar. Where have I heard this problem from? Alright, so this looks like just from the lecture one. So we're going to go ahead and calculate this, which again, we have to figure out the confidence level. And this time, it is 90%. So we'll go ahead and find the z value for 90%. So we need our table, calculator, 0.90 divided by 2, and we're looking for 0.45. So close. Looks like right here would be it, 1.64. 1.64. Okay, almost there. 1.64 for 90%. Alright. So, now that I know my z value being 1.64, we're going to go ahead and insert everything. Use the formula. 0.65. Actually, so I'm going to show you the formula so you know where I'm at. It's this formula right, right here. Okay, so this is where we get our formula. So z value, we're going to start with that, 1.64, divided by our margin of error, which is 0.03. We're going to square it. Okay, and then we're going to multiply it by 0.65, and then multiply again by 1 minus 0.65. Comes out to 679.87. And again, since we're looking at sample, we're going to have to round it up. Okay. So for us, sample size is 680. Check. There we go. Okay. How large is the sample size necessary to be if no estimate was available? Okay. So again, if there's no estimate available and we're trying to figure out the sample size using this method, it reverts to 50. So, calculator. Since I've already figured out, if I'm using this number, let's square it again. Oh, it squared the whole thing. Let's clear it. Go back to history. This one. Okay. Square it, and now we times it by 0.5, and another 0.5, ends up being 748. Okay, using the calculator does help. It's the same formula. So again, formula right here. Let's make that bigger. Alright, so I took X in the first one, which was 65% because we knew the estimate. Multiply 1 minus 0.65, and then our Z value, which was 1.64, divided by our margin of error, 0.03, squared. That's how we got that math. Okay? And then on this one, since there's no estimate, if there's no estimate, X becomes 0.5. So really it's taking this part right here, the Z value divided by our estimate, our margin of error, squared, times 0.5 times 0.5. And that's it. Okay, question 6. Let's see, it looks like we have a T table again. So, an important factor in selling a residential property in the number of times a real estate agent shows a home. A sample of 21 homes recently sold in Buffalo, New York area revealed a mean number of times a home. That seems a little weird. Number of times a home, there we go, was shown was 23 and the standard deviation of the sample was 8. So again, we have an unknown. So we need to figure out our T value. Okay, so going back, let's figure out T value. We know we have a 99% confidence. So to our T charts. So now we're here at 99. We'll put that in pink. So that's the 2, 3, 4, 5th column. Then we gotta find our mean number of times for our sample. So our sample size is 21. So minus 1, that's 20. So always our sample size. So back to our chart. Go all the way to 20. 1, 2, 3, 4, 5. So it is going to be 2.845. Okay. So we'll come back to that in just a sec. We're going to go ahead and take our standard deviation. So calculator, 8 divided by our number, which is 21, sample size number. Remember, we got to square root that number. And then from that, 8 divided by our square root of our sample size. We're going to multiply it by our T value, which was 2.845. Okay. We get around to the 3 decimal places, which will be 4.967. Check. There we go. And then, of course, confidence interval of the population mean between the two is we're going to take the 23 and add and subtract. So calculator, 23 minus 4.967, 18.033. And 23 plus 4.967 is 27,967. Check. And there we go. There's question 6. So the hardest thing right now is finding the margin of error. Remember to use the proper formula. It's all about formulas in these now chapters. Alright. Question 7. Alright. Pharmaceutical companies promote their prescription drugs using television advertising. In a survey of 76 random sample television viewers, 19 indicated that they asked their physician about using a prescription drug they saw advertised on TV. What is the point estimate of the population proportion? Okay. So for this, the point estimate, again, is going to take the calculator, 19 divided by 76 is about 25%. Okay. Again, just taking who indicated about it and divided by the total in the survey. What is the margin of error with a 99% confidence interval? Okay. So this one, since it's 99%, we need to find the z-value. So back here, again, I would say write down all the ones with the z-value and the common ones, because you don't want to keep going like I'm doing and have to go back through and find it. 0.495. So right there, that was 2.57. Yeah, 2.57. So again, have to remember it's 2.57. We're going to take our calculator, since this is dealing with proportion again. We're going to take our proportion size, 0.25, and multiply it by 1 minus 0.25, divide it by our population size, or our sample size, sorry, of 76. Okay, and then we get to do square root of it. I think it messed up there. Yeah. There we go. So the square root, and then multiply it by our z, which was 2.57. Ends up being margin of error of 1.28, or round to 2 decimal places. Ooh, almost got caught there. So 0.13. Okay, and then of course we do the same thing. We want to add and subtract from 25%. So calculator, 0.25 minus 0.13. It's going to be from 0.12 now why it's once 3 decimal places. We go with it. Either way. So, 3 decimal places. Maybe if it got more complicated. Okay. So, 0.380. Oh, yeah. I missed part of the formula. My bad. Okay, let's go back to the formula. Formula! PowerPoint. Okay. Looks like we have an issue going on. I think there's an error that has actually happened here. Unless it's going really specific with this one. So, let's see what's going on. Okay. So, calculator. So, we're going to take this 0.128, since we're not going round by 3. So, 0.128. Minus 0.25 or plus 0.25, 0.378. Let's see if that is it. Okay. And then we take .127, 128, so 0.25 minus 0.128 0.1 Okay, there we go. Alright, so gotta watch out for that then. Okay? Even though B is having you round to 2, because it really is just the margin of error or that we calculate, add and subtract to our percentage, but because they're doing by 3, which really they should have done this by 3 as well, that's what it's going to get you on those last bit. So it's a little bit of a rounding issue. Okay, cool. And then of course, is it reasonable to conclude if it's going to be in or not? Alright, let's see what 8 has in store. Okay, so again, we have 3. Looks like High Tech Incorporated randomly tests employees of the company. Last year it was 500 random tests, included 14 employees failed the test. It looks like the same, except this one actually does 3 decimal places as the last problem, as problem 7. So I'm not going to go over this one. This one I'm going to test your skills. See if you understand. At least this one, again, is 3 decimal places besides 2 decimal places. They don't know why they did that. Anyway, and then watch out on your confidence levels. as this is 90, not 99. Okay. Question 9. Alright, question 9. A survey of 28 randomly sampled judges employed by the state of Florida found they earned an average wage, including benefits, of $65 per hour. The sample deviation was $6.14 per hour. Alright. So this one has both. Nice. So we're going to go ahead and do this one. So what does the population mean? Okay. So again, for this one, our population mean oh dang, all of a sudden my mind just went blank again. Should be $65. Yeah, I don't know why I'm thrown off for some reason. There we go. Yeah, it's $65 again. Population, when it's an estimated population mean, it uses the same mean as the sample. I think it was like, wait a second, t-distributions. There they are again. Why are we using just throwing in there to throw a loop, and it kind of just made my brain just pause right there. Alright, develop a 98% confidence interval for the population mean wage, including benefits for these employees, using our t-distribution. Alright. So with this, again, we need to go ahead and find our t. So go back to our charts. T distribution, and we have 98%. Okay, and then our sample size was 28, so that means on this, the degrees of freedom is going to be 27. Okay, so 27. And 98% was 1, 2, 3, 4. So that's the fourth. Right here, it's going to be 2.473. Okay. But first, we're going to do our division, which is taking the standard deviation of the sample, 6.14, divided by the square root of our sample size. So 28 square root. It's going to be 1.16 times multiplied by our table, which is 2.473. So it ends up being 2.86. Oh, it's rounding your answers to 2. So since it's round our answers to 2, we're going to go 2.87 plus our 65 equals 6787. Okay. Calculator 65 minus 2.87, 6213. Okay, there we go. Now all we have to do is figure out our z value. This one right here, sample size. Alright. So for this, we need to first find our z value, which is this for 95. So going back to our table, we already know for 95 it's going to be 1.96. So we're going to take our calculator, take 1.96, multiply it by our standard deviation of 6.14, and then divide it by our margin of error, which is $2, and then we square it. So it ends up being about 36.21. Oh, round. Yeah, we got round to the nearest whole. It's a sample size. I'm so used to it now with all those. Yeah. So it's going to be 37. So there's question 9. So last question. See if this looks anything familiar. So it's just a bigger version of question 9, just a little bit more spaced out, which actually has you figure out the standard deviation right here. So 650, 35. Okay. And then it's calculate the standard error of the sample mean, and then of course the interval. So remember, sample error is going to be our t-value calculations. So this is really something we've already done. It's just it's more spread out. So I think y'all can handle this one as a good test to see how well you understand the skills of this chapter. Again, if you have any questions, please let me know. I'll get right back to you. So that concludes Chapter 9 homework. I will see you for the next homework.